Now let us discuss about regression analysis. In 1877, this word was propounded as a regression by Francis Galton. While he was studying relationship between heights of father and sons. So afterward it was used in different statistical analysis also. Regression is a statistical tool with the help of which we are in a position to estimate or predict the unknown values of one variable from known value of another variable. एक वेरिएबल ਦਾ ਸਾਨੂੰ ਅਗਰ ਕਲੀਅਰ ਕੱਟ ਇਨਫੋਰਮੇਸ਼ਨ ਹੈ ਤਾਂ ਦੂਸਰੇ ਵੇਰੀਏਬਲ ਨੂੰ ਅਸੀਂ ਫਾਈਂਡ ਕਰ ਸਕਦੇ ਹਾਂ ਰਿਗਰੈਸ਼ਨ ਟ੍ਰੈਂਡ ਦੇ ਮੁਤਾਬਿਕ। ਇਹਦਾ ਕੋਰਿਲੇਸ਼ਨ ਨਾਲ ਕੀ ਡਿਫਰੈਂਸ ਹੈ? ਕੋਰਿਲੇਸ਼ਨ it is a mere degree to measure the degree of relationship, but regression is a study of nature of relationship. Nature means characteristics. When there is a equality or similarity between the relationship, any type of cause and effect relationship is there, then it is what is a cause and how much it is affecting, that is number by which relationship exists. Correlation is just a degree of cause and effect, but it is not telling whether it is actually cause or effect. So in the diagram we can see there is a initial A, that is the initial amount of one thing is there which is not affected by other variable, but when there is a change in y and change in x, that is what is changing in x and what is changing in y, that ratio is affecting, that is we can say this b. Here it is a y on x, y we want to calculate and y on the basis of x, so y is equal to a plus bx. So this is a regression line or regression trend. So we will calculate this by on x or bx on y, that is x if y is given. Here if we are having x and we want to calculate y, it is a by on x, so change in y over change in x. So this is the main thing which is telling about the ratio with which it is affecting. So we will discuss the method of calculating regression in mainly 4 parts, and out of those first 3 parts are there: methods of least square, and regression is calculated from arithmetic mean, regression is calculated from assumed mean, and afterward we will discuss in the frequency distribution how it is affecting. Regression in the case of method of least square, which will be discussed first of all, that is x on y, it will be having this formula, that is the sigma x is equal to na plus sigma plus b sigma y, and second equation bx sigma xy is equal to a sigma y plus b sigma y square, and so on. So this will be explained in this method, and how these equations are formed, that will be also discussed. In case of arithmetic mean, that is the actual mean, the formula will be sigma xy over sigma y square. Now you can see that it is similar to correlation. How it is similar? On the numerator side it was same, sigma small x small y, over it was a sigma x square and sigma y square under root, but it is a x on y, we will ignore x over here and we will take y, and under root sigma y square will be multiplied with the under root sigma y square. So it will be, that is this part y, that is at the back, x on y, that will be here, and above there will be sigma xy only. At case of y on x, we are having byx, that by and x will be calculated by sigma xy, and now it is a last is it is a x. So x will be here sigma x square. So it is having relationship with the correlation also, but one thing is there, only one part is in the denominator and that is squared, and other part is not available over here. So it is the x on y or y on x. When we will calculate in the case of assumed mean, that will be n sigma dx, same we have done in the correlation, and divided by sigma dy square. See, x on y, so y is at last, so here only y will, that portion which was under root and of y, that is squared. Under root has been removed by squaring it, and other part x is not here as it was in the correlation. Y on x, n sigma dx dy minus sigma dx sigma dy over n sigma dx square minus sigma dx whole square. The fourth method we will discuss, that will carry f over here, sigma f dx dy, sigma f dx, sigma f dy. So wherever d is here, we will product it with the f, sigma f here and sigma f here. So everywhere f will be there, that will be fourth part. So now moving toward the next, that is the least square method. So method of least squares, suppose we are having data of two variables x and y. X we are having 1 2 3 4 5 and y is 2 5 3 8 7. So write down x over here and y values. So sigma x is 15, sigma y is 25. Now square it, x square will be 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, so on. That is a 55 total is there. Y square we have 2 square 4, that is 5 square 25, 3 square 9, like that we have calculated 151. X y, so x into y, 1 into 2, 2 into 5, 10, 3 into 3, 9, so on, we have 88. So how we will calculate? Calculation of x on y. So x on y, x will be calculated on the basis of y. So first we will discuss x on y. So x is equal to, that is the autonomous x a plus b, that is the b x y over, because it is a x on y, so b x y. bxy into y. So ratio of changes in the x due to the changes in y will be bxy. So next is aggregate of x, sigma x, aggregate of a, na, aggregate of y, sigma y. So first equation is here. Second is we will multiply all the parts with the y. So sigma xy. So n time y is coming, sigma y, a sigma y in, that is a sigma y square. So it will be second equation. Now we will take the values over here, 15, that is sigma x, n number of observations are 5, we have taken 5, a plus 25, that is our sigma y, b, and 88 is a sigma xy is equal to, that is sigma y a plus, that is a sigma y square, 151. So these two equations 1 and 2 we have filled. Now they are not having any common element to deduct it. So first of all we will equate them. So we will equate each and every item to make it equal to the other equations, any one item. So 5 and 25 are so much similar, so we will multiply 5 to each element. 15 into 5 75, 5 into 5 25, 25 into 5 125, and the second equation will be as it is. So what we will do, we will change the signs. So plus is changed to minus, plus is changed to minus, plus is changed to minus. So it will be cutted because it is a plus and it is a minus, 0 is there. So minus 13 and minus 26b. So calculation will be that b is equal to 0.5, minus minus deducted, and 13 over 26, it is a 0.5. So put it in any one equation. So we are putting in here 15 is equal to 5a plus 25 into 0.5. It will be after calculating a will be 0.5. So now put it in the equation. Equation will be x. So for starting equation, x is equal to a 0.5 plus that is a 0.5, it is a b we have calculated, and y. So this is a regression equation. Now after that we will calculate y on x. If we want to calculate y on x in the same question as we have discussed, so y on x, that means y is equal to a plus bx. So sigma y as it's same na plus sigma x, sigma xy. So n time it is a x is multiplied, so sigma x a, b sigma x square. Now put the value same way and we got b equal to, that is we have made two equations. Then to make it similar we have multiply all the elements of first equation with 3. So 75, 15a, 45b, and then changing the sign, deducting this, and we have got minus 13 is equal to minus 10b, and b answer is 1.3. Now put the value in equation, that is 25 in the first equation we have put it 5a plus 15 into 1.3, it will be a is 1.1. So regression equation for y on x is y is equal to a 1.1 plus b is 1.3 x. So this was the method in case of method of least square. So after least square we will move toward regression from deviation taken from arithmetic mean. So formula of x on y, that is sigma x y over sigma y square, as I have discussed it earlier, that is it is close to correlation, but difference is there. It was under root sigma x square and sigma y square, but because it is x on y is at last, only y will be here and x will be removed, and under root will be removed by squaring it. So here it is a formula, we will calculate it, and y on x is the same way, sigma xy over sigma x square, because x is at last. So equation will be x minus mean of x, bxy, that is the x and y derivative, that is a regression, y minus y mean. That will be equation for x on y, and this will be equation for y on x, that is y minus y mean is equal to byx, x minus mean. Take example over here that salesman's figure number are there, and they scored in the test, and they were given the chance to go for first sale of there, and they have shown in the thousands, 2.5, 6 and so on. So we will calculate the regression, that how much they scored and what is the relationship with their actual sale performance. What is the correlation of the scoring and actual practice. So we have taken x, that is a test score is written over here, that is sigma x, and that is total is 600 of test score. So 600 divided by 10, it is a 60. So 60 is the mean of x. So we will calculate the actual deviation from actual mean. So it is 40 minus 60, 70 minus 60, 50 minus 60, so on. And sigma small x is equal to 0. Now x square, small x square, that is a 400, 10 square 100, minus 10 square 100, and so on. We have calculated sigma small x square. Y we have taken sales, and that is written over, and total is a 40. 40 divided by 10, 4 is a actual mean. Deviation from actual mean, that is a y minus actual mean, we have calculated, and total is 0. Then we will calculate sigma y square small y. See, if we want to calculate it deviation from actual means, it will be total will be 0. Again, sigma small x and sigma y will be always 0 because they are taken from actual mean. So sigma y square we have calculated, it is there, and x and y multiplication is here. X we have calculated minus 20 into minus 1.5, that is a 30, 10 into 2, that is 20, so on. We have calculated, it is, that is the sigma xy is 130. So we want to calculate y on x, suppose. So y on x will be byx sigma xy over sigma x square. So what will be there? 130 will be here, that is the sigma xy over sigma x square, that is 2400. So it will be 0.054. Now if we want to calculate y on x, so equation is y minus mean. Y minus mean is 4, and we have calculated byx 0.054, and it is x minus mean of x is 60. We are going to calculate y is equal to 0.054 minus 3.24, and if minus 4 will move here from to the right side, it will be plus 4, and total will be y is equal to 0.76 plus 0.54. This will be equation for this, and that is the regression taken from arithmetic mean. In the second part we will discuss about the assumed mean and frequency bifurcated mean deviation, and from that we will calculate regression. Thank you.